It's like I don't care about nothing, man. Yeah. Oh,
All right, so this video was all about reflections. So we're all about flipping everything on its head. So the idea is we're flipping over a line. So you'll see that there's actually 4 different types of algebraic descriptors that we're going to use. So your success criteria is by the end of this period or whenever you're watching it to know the different algebraic descriptors for reflections. So a reflection or flip, because that's what a reflection does, is a transformation over a line called the line of reflection. Really creative by the person who called it this. Each point of the pre-image and its corresponding point on the image are the same distance from the line. A reflection is a blank transformation. So what we are going to say is since the size does not change, it is rigid. So the size and shape of the geometric figure stay the same, but the orientation is flipped. So with the pictures below it, it says a reflection has the following properties. If a point is on the line of reflection, then the image and pre-image are the same point. So, for example, here, A was on the line of reflection, so they both shared the same point because it's already on the line. Now, if the point is not on the line of reflection, the line is the perpendicular bisector of the segment joining the 2 points. The distance of the corresponding points to the line of reflection are the same. So if you drew a straight line, let's say to D and D prime, when it goes through this line, it would be going through at a 90-degree angle, and both sides would be the same. That's what they mean. So if I go to draw the new one down here, you would want to just, one way you can do it is just literally count how far away from the line it is. So F is 2 away, so I'm going to go to the other side and go 2 away. So this is where F prime would be. G was 4 points away, so I'm going to go 1, 2, 3, 4. So this would be where G prime is. E was 2 away, so 1, 2. So this is where E prime would be. And H was 7 away, so I'm going to go 1, 2, 3, 4, 5, 6, 7. And this was H prime. So now if I connect all the dots, you're going to go, holy gee willikers, they look the same. And as they should, because they are supposed to be congruent. And I am just realizing now, 1, 2, 3, that G is supposed to be 1 closer. So I made a mistake. Do we think I'm going to redo the video? Gosh darn, we know I'm not.
It's Brittany, bitch.
So just realize that I miscounted. So I made a boo-boo. So up here we have a list of the different types of algebraic descriptors that we're mostly going to use. So one is reflecting over the x-axis. So if we do that, it's going to have the x stay the same value and the y is going to change. So if it was positive, it would turn negative. Reflect over the y-axis would be where we see the x change, the y does not. Now if you have a reflect over the line y equals x, which means it's a positive sloped line, then it would have it where x and y flip. If it's having a negative slope line, then we flip them and both signs change. So if I'm doing a reflect over the line y equals x, it's a positive slope line. this one would be a negative slope line. And in case you need to see how these ones look, the x-axis is the one that goes horizontally, y-axis is the one that goes vertically. So it would be flipping over those different lines. Okay, so reflect the triangle over the x-axis. So this one is our x-axis, so we're trying to make this go from here to here. Now, one way is to remember the algebraic descriptor. So it said that the x stays the same. So let's say if I'm doing a prime, I know my x stays the same, so it would still be 2. The y value is supposed to change signs. So if it was positive 3, it's now negative 3. So a would be located to the right 2, down 3. 1, 2, 3. This would be our a prime. The other way to find it is to look at the point and see how far away it is from the line. So b is 1 away from the line, so if I also go down 1, then this would be b prime. So b prime, even by doing that, you'll see we ended up using the same rule. Stayed at 3 for the x, and now we're at negative 1 for the y. And then c prime, again, the x stays the same, so it's going to still be at 1. But instead of the y being a positive 2, now it's negative 2. So c still be at 1, now it would be at negative 2. So this would be c prime. And now you get to have the fun task of connecting the dots. And you're going to go, golly gee willikers, coach. It's the same size, same shape, same angle, so this must be a rigid motion. So it doesn't ask for it, but again, a good thing to know. So the next one, you were saying that the reflect over the x-axis was too easy, so now we're going to try to reflect over the y-axis.
No, God! No, God, please, no! 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 No!
So this line here. Now, from the rule that we have above, I know you can't see it on here, but it says that we change the x value, y stays the same. So instead of the x being positive or negative, I mean it's going to be now positive. And the y stays the same. So m prime would be at 5. So to the right 5, 1, 2, 3, 4, 5, down 3, 1, 2, 3. And this would be m prime. So this flipped over the line. Now again, the other way you can do this, if you don't want to remember that, is just think about if I were to fold it in half, where would it be? So this one is away from the line by 2. So if I go over 2, I got my new point there. So a prime was at 2, negative 3. So t prime, again the x value changes, so now this is going to be at 2, but the y value stays the same, so negative 5. So to the right 2, down 5, 1, 2, 3, 4, 5. And that would be t prime. H prime, still the same rule. X value changes, so now it's positive. Y value stays the same, so negative 5. So I go to the right 5, down 5, and I found H prime. So I can just connect le dots, and golly gee willikers, again, same size, same shape, same angles, so it must be a rigid motion. So Now it wants us to graph the image of GEO reflected over the line y equals x. So it's going to have a positive sloped line. Now, we gave you the algebraic descriptor on the page before. So if you don't remember the algebraic descriptor, for it when it's y equals x, so y equals x will turn into y comma x. So the idea is we switch the x and y value. So this goes with our success criteria for knowing the algebraic descriptors for a reflection. So there's multiple ones you need to know. This is one of them. So I'm going to pause it and label GEO before we go to find the new places. So I've already set it up so we're almost able to do our arrow notation. So we said that all they have to do is switch the x and y value. So for G prime, it would turn into -1, 1. E prime would turn into 4, 6. O prime would flip and become -5, 3. So if I go to graph this, G prime is at -1, 1. So right here. E prime is at 4, 6. So to the right 4. 1, 2, 3, 4. Up 6. 1, 2, 3, 4, 5, 6. So that one was E prime. And O prime is to the right 3. 1, 2, 3. And, oh, sorry, O prime is at -5, 3. So to the left 5. 1, 2, 3, 4, 5. Up 3. 1, 2, 3. So now if I go to connect them, I'll try to make it a little bit straighter lines this time. When I draw this, you're going to notice that, again, they look the same. They have the same angles, same shape, same size. So it is a rigid motion again. And the idea is that the line that it's flipping over would be somewhere in the middle. So something like that. So it's getting flipped over an imaginary line that I just created. So when you do this, the idea is all we do is flip them. So number 7 on page 4 says reflect over a horizontal line. Graph the image of math over y equals -2. So when you do this, what you have to do is first draw the line that they say. So they said y equals -2. So that means I go down 2, and the line that they're talking about is right here. So you're creating the line. And each of the points have to reflect over it. So you're going to find out where each of their primes are going to be based off of this line. So for instance, H, since it's on the line, that was one of our rules from the first page, this becomes just H prime, because H and H prime are the same spot because it's already on the line. Now other points like T, that's going to move. So it's 2 away from the line here. That means I have to go 1, 2 over here. Now I want you to practice the other 2, but you'll see that it's going to end up having the same shape. The only thing is it's going to be flipped. So I want you to try the rest of it, and then I can check it in class. So you can either send it to my remind, or if you're in class, just show it to me in class.
Boo! You stink!
Okay, so number 9 says suppose the line segment with endpoints C at 1, 3, D at 5, 2 is reflected over the y-axis and then reflected again over y equals x. What are the coordinates of C double prime and D double prime? So it's going to do two different reflections. So I'm only going to show you C. I'm going to want you to do D yourself. So for C, the original point is at 1, 3. That's the original point. If I do a reflection over the y-axis, the y is what doesn't change. So the x value will change, the y value will not. So when I do that to find the prime, so this is going to be C prime, is going to be located at -1, 3. Because again, the y value did not change. The x value did. So now, reflect over y equals x. We did this one on the page before. Whenever you do this, the rule for this is that you just flip them. So whatever used to be the y value now becomes the x value. So when I go to do C double prime like we have here, I would have, since it used to be -1, 3, now it would be 3, -1. So C double prime would now be 3, -1. So that's the end of another video. This one was all about reflections. So remember that the rest of this packet that I did not go over is practice for you. And practice makes perfect. So make sure that you're looking over the different algebraic descriptors. So like if it's reflecting over the x-axis, you should now know that the x doesn't change, the y does. If it says y equals x, so if it's positive, then I know I'm just flipping them. And you want to make sure you know all four. Those are just two examples. So I hope you found it informative and have a good rest of the day.